Apparently we are live again. Good morning. Yeah, let's uh, see the description for exercise 3.12, and hopefully you can hear me well. I removed the background music. No. So write a function that returns the reverse of a list. Given list 1, 2, 3, it returns list 3.321. See if you can write it using a fault. Okay. Uh, I think I didn't put this in the, or I left the the previous URL in the description for this live. So once the live is done, I will put this into the description. Well, in fact, there is nothing here. There is no testing. I mean, property-based testing like the first videos. Um, this is only like a recapitulation for the last exercise. And just to tell you that you can also use this notation even when you are using fold left. So now let's change this and use reverse. And here too, reverse. And this shall return 5, 4, 3, 2, 1, and in here, well, it is on the empty list. Okay, we have our data type. If you are like new in this series, we have fold right present, we have fold left. The exercise doesn't, uh, it, it is just asking to write a reverse function. You can also have append. It is provided in the book. It is not constrain you, you know, to use. You can do it however you like, but it also suggests you and to see if you can use a fault. And I don't know if you remember on the book they say sorry, that fold right starts folding from the right. I mean, you have to fold right traverses the entire list, you know, like this. See the mouse, and then it starts folding back to get you a final result. Okay, it is not stack safe. Sorry, no, really sorry. uh, uh, fold left. Mm, well, this is this starts folding from left. It grabs the first. This is stack safe, so it grabs the safe. The first. Uh, how do you? Yeah, the first element, the head, the first element. Yeah, and the accumulator, and it goes throughout the list. Look at the mouse. Look at the mouse. Look at this, and once it hits the end, it gives you a result. Okay. So you can use this knowledge and the exercise in 3.8. They were asking that you experiment passing a list to this fault right. If you pass this 1, 2, 3, 4, 5 with this operator, with this function, well, okay. I would say it is a function, constructor function. Well, okay, you can say it's an operator, and it will give you the same list in the same order because it traversed the whole list. 5 nil, 4 5 nil, 3 4 5 nil. See, but now let us see if fault left will give us the list in reverse order because it will grab 1 nil, 2 1 nil, 3 2 1 nil. That seems like the way to go. So we are going to write reverse. Um, remember in our previous video we made the mistake. We were too quickly to put this sum as a polymorphic type, but you know, unless you define the plus operator for all the types, you can define it polymorphic. But that's not the case, so we constrain the type to int. Now reverse doesn't need to be like that. So it is a polymorphic function. We are getting my list. A, and we are um, returning my list A. Now we can use fault list as we have said, and we pass the list. We pass an accumulator. I'm not sure if this will give us trouble. I'm saying this because sometimes in a Scala you have to annotate. You know, in a Scala sometimes you need to do something like this. Well, we will see. And now the function. Okay, so it expects two parameter function. The A, what's gonna do with this? And hopefully that will do it. Let's hope for the best again. And if it's not, well, we will be in trouble because I don't want at this point to be thinking in another implementation for reverse. So let's run this. And oh my god, there is no exercise in which we can just implement these functions at the with hitting how do you say some compilation. Okay, found background nothing, my list of nothing, required nothing from A. From A, Um, it required playground my list of nothing. Most likely is it is what I was telling you. Um, if we go to the book, to the exercise 3.8, they are using this notation, uh, so they avoid, this touch. We will do that to see how it goes. But I think here, there's something here. Let's instead do this, and if it works, we will have to find an explanation. We will get away with just, hey, it worked right. But it will be the same, like, no, there's something here. With this, I'm not convinced at all with this. But I'm not sure if we can annotate, uh, sorry, this. Let's try first to understand the error. Again, sorry, very a little bit ill. Um, three, three. Nothing is the same. So the default left is A. We are passing A. Ace, sorry, ace, which is this one. Now the accumulator, which is of type B, and we are using nil over here. Yeah, it should work. It should work. Nil, and then there comes mhm, again, it is empty of A. Do you think? Well, let's go back to the explicit version because let's think for a while if we can. Um, you know, because this uh, this this is a function from B and A, and therefore to B, and cons accepts an A and a B, you know, and we were passing. I think we were doing right. I think I'm not sure why it doesn't like this. Uh, we are getting B, which is this B, and A, which is of type an element on A, and then pretty sure why I'm not sure why it's not working. It's, cons needs an A over here, a B, and letter C. And if it's not wrong, we will have to, now guessing, because I really not sure if this, if we need to, it is, it is, it is still saying that it is a list of nothing, which is wrong. I'm not sure if we will have to annotate. Let's see. Now let's annotate the type. As I said earlier. Now what does it say? Okay. I'm not sure. This is like probably so wrong. You see, like the suggestion value new in object list does not take any parameter. So again, we can do reverse. It's kind of easy function, but I don't want to implement it right now. I want to use this function, maybe this with an append. But this, I'm not sure what is the problem. Once you once you know pass the design phase, uh, like to start thinking. We're going to do just that. But okay, so this is new. And there was a discussion that nothing, it is a subtype, even this annotation plus I was like nothing is a subtype of A. But then the problem is here. Let's find again. We remove the A so we can back to our error. Original error. Found A. Even if nothing. B is my list of nothing, which is in relation to this. Okay. Again, I was thinking this will be straight forward. This nothing required, nothing required, nothing. Maybe we need to switch the functions, the parameters. But if this works, we will have to explain why. Thank God it doesn't. Found my list. Okay, found like on my list of nothing. found B of type A. Yeah, we are still my list of A is my list of nothing. It doesn't matter how do you name this. You can do something like this, and this is still the A. Have a look. I am trying to see the. Okay, when I was writing, okay, why? Okay, why if y is of type A, so you get the idea. Now, since we are having troubles with the types, let's uh, see again this function. Okay, the accumulator is of type B. I, this has to be like this. It has to be nil. I can't think of another accumulator. Required nothing. Found. Okay. Found A. Playground list of nothing. That'll see the time. Oh, oh my! I don't have. Give me a minute. Okay, I was. We're running out of battery of energy, and we are also running out of time. 23 minutes. I was thinking this will take me 5 minutes. Unbelievable. Sorry. Okay, I have my notebook here. Okay, yeah, I don't get this. Okay. Sorry, I'm really sorry. Probably I shouldn't make this live today. But now I am in the situation, and we have to, even if we need to see the solution, we will give ourselves uh, uh, 44, maybe 15 minutes. And if we don't find an answer, then we will see the solution So we need to put chronometer. What's this? Timer. What's this? What's that? Okay, here. 12, 30. Yeah. If we don't get the solution right, no. 21, 31, 5. If we don't get the solution by this point, by this point, was it the answer in my GitHub repository, because I did this years ago, and other programming languages, in the imperative approach. Okay. I'm not sure about how to proceed here. And I didn't, I want this to be like sessions. Could you not solve this like yesterday, the entire day, and come here and say, hey, it's 5 minutes. Okay, so what do you do in this? Maybe we should be stubborn and use another approach, but I think this is the way to go. Somehow, I feel this is the way to go, because it starts processing the list one element at a time, accumulating the value. If you think it is straightforward, you say, well, just this is the list. You're asking for a list. Here's an accumulator, you know, yeah. And this is accumulator, yeah. And here's my function, which is const xy, which is how they are using in the book. But look at this. They are annotating this with this type annotation always is needed here, because otherwise Scala has to be type parameter in the profile of nothing, which is what's happening to us. And let's use volt left in the Scala in the Scala system. Where is this? I'm going to testing, and this, and this, and come back here. Now we are using the Scala library. But in the Scala library, you have to list, list 1, 2, 3, and you have your functions. Look at this, all right, and we pass the parameters, which is I don't uh, list empty, and well, I'm not sure if she will have headphones. We uh, how do they have tones? No, but they have this operator. I suppose this do. I'm not sure if this is going to work too, because now convert type insert type for the A parameter function. So int still well let's help I think what nothing happened. My mother is now need to something. So in here again, this is like a function application. Mhm. Let's try to print this. It will be the same result. The no, I want to. It happens to me a lot. It happens to me a lot. If now it is I don't know expression. Now they do what we have here. Since um, way, yeah, we need to apply. Why this what's this? Oh, what? I think we will have to use the solution for this problem. I didn't want to, but the time is. Mm, I'm not sure what's happening either here. So I don't remember this other way. Okay, I remember another notation, syntax. Mm, I think it will be the same result. This is a mess. Okay, I remember something like this. Since this is the last parameter, I don't, I'm not so sure right now. I'm not so sure. And if it works, it will be probably the same like as this because I am only changing. No, look at this. We have some result in here. You know, one, two, three, one, two, three. You see, it likes this notation better. Now let us see if we can replicate this with for left. And yeah, I'm not sure. Uh, Probably we'll have to switch. Yeah, I was thinking that. Found is clean list int and required list int. Yeah, because the accumulator is now. Let's look at this here. Well, again, we are seeing our function, but right? The switching the parameters. Uh, Okay, this is this is given that we did it right, but we use the Scala implementation of fault left. Uh, so exercise to the reader for me too. Why? There are several questions over here. Why this syntax in which we are passing the function inside the parentheses gives us give us gives us gives us this expression, lambda expression. And when we use this alternate syntax with braces, we get the result. That's first question. Because that's the Scala, that's how Scala works. Why it works like that? What's happening right there? What's going on? That's the first question for you and me. Probably you know the answer. I don't know right now. I forget about it. Maybe I read it. I read it about it at some point. Um, and the other question, the fold left, it gives you the list in reverse order, which is the exercise, what the exercise was asking about. And I was thinking that the fold left is the way to go because, and mm, I wasn't, I didn't want to use another function as you saw throughout the process, not even the imperative way, because this is so great, you have this function, general function, that is a machinery that you can apply and avoid all sort of intermediate thinking for yourself and just come up with an expression like this and have to resolve. I mean, I suppose that once you go in the functional approach, well, it's not like the functional approach, but once you see that you can come up with these answers that avoids you to the cognitive load of mutating or specifying an algorithm. You don't want to, I mean, you want to write an expression and avoid the do this and now this and several steps. Nothing wrong with that. I use it in other languages. You can deny that this is good. Um, so the second question is, why were we a, why were we be able to implement this function with the faultless in the Scala library, but we couldn't make use of our faultless implementation with our type or explicit data type. I missed something. What's the point of having you wait for to the next Sunday if we can see the solution right now and see? Because for me, I we were using the same approach, you know. We were giving this meal. Where is it? Here. We were given the list in here. Yes, meal, the accumulator, and we were given this A. Where is it? Where is this accumulator? Here is our accumulator, which is here. Meal. And we were given this function. We are given this function, and we were doing just that. No. So why it didn't work for us? Why it didn't work in here with our cons, which expects an A. We did this, remember? The problem missing here, I suppose. Why? Okay, two questions because we need to leave. Um, regarding Scala, why this gives you a lambda expression, and why does this gives you the answer with the braces, you know? And the second, more importantly, for learning or academic, yeah, for our learning uh, with the book, why this, why it didn't like this. I have the solution in my GitHub account. I will see it. So the next time we will start with that. Um, yeah, for now, happy Sunday, and we we implement the partially the solution because we are not we didn't to be honest we didn't solve the problem because we only demonstrate that faultless works as a solution for reversing a list. That we only demonstrate that fault left can be used to reverse a list. That's what we did at the end by using the Scala library. But we didn't solve the exercise, um, which was implement reverse with our implementation of a list with nil and counts. That wasn't solved. So you want to continue then to spend the entire day, you are welcome to do it. I'm not doing that. Not these days. In the past, I did it and I solved it, but not right now. I have to do some other things. Some, you know, I have to complete some animation that I'm doing in Blender. Let us see if it's over here. Besides, I like to play the guitar, study some geometry, and only after that I can come back to the exercise. Look at this. We are having this pick to the upcoming animation, you know. I think you will like this one. So see you in the next. Uh, yeah, time to go. My God, 50 minutes. We need to say goodbye. So bye. Let's enjoy it.